Yeah. Now that we have identified that the independent factors are really not independent, that is where we look at reducing the dimension. So probably 5 factors are not required. They may get clubbed into 2 factors or probably 1 factor or whatever. They can be clubbed together to form 1 or 2 or 3 factors. That is what we are calling as factor analysis. So the tool typically does the factor analysis from analyze. Dimension reduction is there. As a part of this dimension reduction, we have factor analysis. So this particular part helps us in reducing the dimension. What we are doing in this process is we have to give all the variables for which we think are our independent variables. So the better thing we are talking of is the engine size, the horsepower, the length, the curb weight. These 4, let's say I am giving as the independent variables, and probably if required let me put even the vehicle type also. These are the 5 variables which I am actually using to determine my price, because the remaining 3 variables we have omitted in the first go itself, where the significance level was greater than 0.05. Then using this, rest all can very well be fair enough. Yeah, how many number of factors you want? Right? Probably sometimes I can decide on a fixed number of factors. So these 5, club them into 2 factors or club them into 3 factors. Or I may say let the system decide that. Right? Again, here there is a complex mathematical or matrices based concept that comes in, which is called as an eigenvalue, which is more like, as I said, the pull out 60% from the second, 30% on the third. What it takes is initially, just I am giving a rough concept of that. Initially, all the 5 variables are given a weightage of 1. Now, let's say this is the first variable I am working on. Some portion of the second variable could be there in the first. Right? Both of them could be to the correlation. The first and second are internally correlated. So, some portion of the second is already existing in 1. Similarly, some portion of the third is also existing in 1. Fourth also is existing in 1. Fifth also is existing in 1. Whatever their portions of the variance, here the portion is from the variance standpoint. Let's say 40% of this, 30% of this, 20% of this, 10% of this is existing in 1. So what happens is this 1 gets upgraded to 2. Because 1 plus 40% of 1 plus 30% of 1 plus 20% of 1 plus 10% of 1. All this put together, it is getting upgraded to 2. So what is left now? This is 0.6 is left, here 0.7 is left, here 0.8 is left, here 0.9 is left. Now the same exercise with the second variable. There could be some portion of the third in the second, some portion of the fourth in the second, some portion of the fifth in the second. So what will happen? Let's assume 30% of each of this is in the second. So 90.9 is, let's say, getting added up. So this second will become upgraded to 1.5. So which will make this one as 0.4, the next one as 0.5 and the next one as 0.6.